Hello, this is my test. This is the third time filming, so I'll go pretty quick. Every time just seems to not work. Okay, so I know there's some errors here. I miscalculated on the big P, little p one, putting it through the forked line method. This should be a 4/16 and 2/16 above and below it, for starters, and so that'll change this data a little bit, and this data, plugging into the chi-square equation, that's going to change a little bit, but these two are not going to change a bit, and those are still pretty large numbers, and so I'm going to continue to accept my null hypothesis, which was that the flowers will follow the Mendelian natural mode of inheritance. That's from a different equation. Ignore that. Okay, so that's the number I need. And I got that by doing the cross, the heterozygous cross, right there, and then multiplying the results by the total number of observations to see what we would have expected. And that's what this is, observed and expected. Okay, so number 2, here's the original cross we did. The probability that 6 children will be affected with, I did the multiplied product rule, which is 1/64 or 1.56%. The second one, we're able to use the binomial expansion equation, which I did right here. Plugging everything in, we get 23.44% chance, and then 6, I multiplied the unaffected values and the unaffected and affected values, and got 1/8 or 1/8, and then I can add those up and get 1/16. Okay, number 3A, autosomal dominant because it doesn't skip generations. 3B, it's autosomal recessive because it does skip generations. I'm referring to this one right here. X-linked recessive because it skips generations, as we can see, and mostly all the males are affected. These females would be carriers, and it's not Y-linked because each affected father does not have an affected son, as we can see. And then the last one is X-linked dominant because in every generation, mostly daughters are affected, because it is in every generation, and mostly daughters are affected. And then all the daughters for father 1 are affected, and none of his sons. So that's a good sign. Number 4, 45 chromosomes are present, 22 tetrads in prophase 1, 45 in metaphase 1, and 90 in prophase 2. Feel free to rewind and pause the video to see what I did, or just look at the downloaded assignment. I recognize that I made some errors on my assignment, but I understood it well enough for the multiple choice and for the homework, and it's just the test that I did throughout the week. It was kind of a hit and miss. I'd do as much as I could, and then I'd move on to my other homework, and then I'd come back and I'd fill it in, move on to other homework, and I'd come back and finish it by today. And I submitted it. Now that I'm reviewing it, I see that I made some errors, and I'm okay to man up to that and take a hit where it needs to be taken from. But I did learn from my mistakes, and I did well, and I will be ready for the next test. But this is just how I did my work. So for question 5, I did the product rule and got 1/64, or 1.56% for this particular genotype. And then for this particular genotype, did the product rule 1/16, or 6.25%. Part C, you start by doing the product rule to find this specific genotype, and then for 5 offspring, I multiplied it with the product rule, getting 9.31 e to the minus 10th. And then here on this last one, because of the OR, I used the summation, and so I found the specific genotype ratio for each particular genotype or phenotype, and then I added them and got 2.34% chance. That's how I did my homework, and I promise I will do better next test. I was pretty overwhelmed, but I'm grateful it's done. So, thank you so much.